Another method of non-conventional energy sources are magneto-hydrodynamic power conversion. So it's a new method in which we are going to utilize the kinetic energy, or we are going to convert the kinetic energy of an ionized gas or liquid into electrical energy directly without using any moving parts. So the main advantage of this system is we are not using any moving parts, and we are utilizing the kinetic energy of the fast moving ionized fluid. It can be a liquid or it can be a gas, but it should be ionized. So we can utilize kinetic energy of ionized fluid, and thereby we can produce electrical energy. So here what we do is we have a duct, a MHD generator or MHD channel or MHD duct. So in this duct or channel or the generator, what we do is we apply magnetic field perpendicular to the direction of flow of hot gases. So here we are talking about gas, but the same principle is applicable for liquids. So the liquid or gas will be flowing in one direction, and we apply magnetic field perpendicular to the direct movement of the ionized gas or liquid. So when we apply magnetic field, whatever the ions which are present, which are charged particles present in the gas or liquid, move perpendicular to the direction of movement as well as magnetic field. And at the top and bottom here we have two electrodes. Depending on the charge present in the ionized gases or liquid and the magnetic field direction, so either the electrons will move towards the top or bottom electrode, and when the flow of electrons or current passes through the resistance or the load, then we get a potential difference across the load and we can utilize that energy. So here we are directly converting the kinetic energy of the ionized fluid, whether it's gas or liquid, into electrical energy by applying magnetic field perpendicular to the direction of the motion of the fluid particles. And in the other perpendicular direction we have kept the electrodes, so that electrodes will catch the charged particles, and when the charge flows through an external load, then we will have a current and we will have a potential difference. So here we are producing DC current. We are producing DC current or direct current. So this, with the help of an inverter, we can convert that into alternate current, and this can be transmitted through our existing grid. There are many ways in utilizing the magneto-hydrodynamic energy conversion process. Here we will start with open cycle system. So in open cycle system we have several components. We have the combustor. To ionize the gas or liquid, either we need to reach very high temperature where the bond between the molecules of the gas or liquid breaks and it forms free ions. Otherwise we can use or we can add some material or some particles which are already ionized. So that process we call it as seeding process. We can convert a gas or a liquid into ionized gas or liquid in two ways. One is, if you reach very high temperature, then you can ionize the gas or the liquid. Otherwise what we can do is we can inject material or particles called seeds. So these are charged particles which are injected into the gas stream or the liquid. So here after the combustion we have the seed injection process, and after that we have the nozzle, then we have the MHD duct as shown in the previous diagram, then we have the air preheater, then we have waste heat steam generator, and then we have seed recovery apparatus, and then we have the removal of dust, SOx and NOx from the flue gases, and then we have the stack or the chimney through which the hot gases will be exhausted, hot gases will be released to the atmosphere. So here in the combustor, what we do is we burn fuel to produce high temperature gases. To burn the fuel, we need air, and that air will be supplied from the air preheater. So this is the air preheater, which is a simple heat exchanger where the fresh air will be drawn into the air preheater, and the hot gases coming out of the MHT duct will pass through the ducts, and the fresh air will pass over the ducts, and the fresh air absorbs heat from the hot gases coming out of the MHD duct. So from here the hot gas will enter the combustor. So this is made because if you supply cold air into the combustor, it initially absorbs certain amount of energy to heat up, and then that will participate in the combustion process. And here we will be losing certain amount of heat energy. So to recover the heat energy and increase the rate of combustion, we use air preheater. And from here we will draw air, and that air will be mixed with the fuel, and there will be an ignition source inside the combustor which keeps the fuel burning continuously. From here the hot gases mixes with the seed particles and then enters the nozzle. So this nozzle is used to control the amount of gases flowing through the MHT duct, thereby controlling the amount of power production. So now on the outer surface we have the magnets. So the air is moving horizontally, or the gases are moving in the horizontal direction. Magnetic fields are applied perpendicular to that, and there will be electrodes which catches the charged particles, and that DC current will be supplied to an inverter which converts that into a 3-phase AC current which can be transferred or transmitted through our existing power grid. And then from here the hot gases will enter the air preheater, where they transfer some of its energy to the fresh air drawn from the atmosphere. From here the hot gases enter the waste heat recovery steam generators. So here we have another steam cycle. So we have the condenser. From the condenser the water enters the waste heat recovery steam generator. Here it gets vaporized, and the hot vapors or steam enters the turbine, where it produces mechanical energy that will be coupled to a generator which produces 3-phase AC, and from here the steam enters the condenser bag. For providing cooling water for condenser, we have cooling tower, which is not shown in this diagram, but there will be a cooling tower which supplies heat to the which supplies cold water to the condenser or cooling water to the condenser. And from here, after supplying heat energy to the waste heat recovery steam generator or to the water flowing in the steam cycle, so the hot gases will enter seed recovery apparatus. So here the seeded particles, the particles which are injected here, will be recovered, and then those seeded particles will be sent back, and during this process, during the recovery process, we will not be able to recover 100% of the seed particles. For that purpose we have makeup seed here. So whatever the amount of seed particles lost here, that will be make up with the help of makeup seed particles which will be supplied at this stage. And from here the hot gases enters a dust removal or catalytic converter stage. In this stage the dust, fly ash will be removed from the hot gases, and the SOx or NOx, the oxides of sulfur and oxides of nitrogen which are formed in during the combustion process, will be removed, and from here the hot gases will be released to the atmosphere with the help of a chimney. So this is the working of an open cycle MHD system. So here it's an open cycle because we are drawing fresh air from here, then that passes through the combustor and then MHD duct, then air preheater, waste heat recovery steam generator, then seed recovery and the dust removal process, and then it will be released to the atmosphere. So at every instant we are drawing fresh air and we are releasing the burnt air into the atmosphere. So this is an open cycle system. Now let us see the different parts in this system. The first part is the gasifier. So the function of the gasifier is to convert the solid fuel into gaseous fuel. Here the solid fuel is coal and the gasification occurs with limited supply of oxygen or no supply of oxygen. So here we have limited supply of air and we need to heat or we need to increase the temperature of the fuel or coal. For that purpose we are using steam and we are drawing steam from heat exchanger 2. Then we have the combustor and heat exchanger 1. In combustor, as the name indicates, we are burning the fuel. So fuel here is the coal gas coming out of the gasifier. So here gasifier is connected to the combustor and here to burn the coal gas we need air or oxygen and that is supplied from the air preheater. So air preheater is a heat exchanger which increases the temperature of the incoming air and that is done with the help of the combustion gases moving out of the heat exchanger 1. The gases moving out of heat exchanger 1 will have sufficient amount of heat energy and that can be utilized in the air preheater. So if we directly leave that to the atmosphere, then we are losing a large amount of heat energy which reduces the efficiency of the overall cycle. So for that purpose we have an air preheater where the combustion gases will flow through the ducts and the fresh air drawn from the atmosphere will flow over the ducts and absorb heat. That hot air will enter the combustor where the combustion of the coal gas occurs and then the combustion releases heat energy which will be transferred to the organ which is coming from the compressor. Then after the air preheater we have air purifier. So when the combustion occurs the temperatures are very high and the formation of oxides of sulfur and oxides of nitrogen are very high and we need to remove them. So for that purpose we have the air purifier where the oxides of sulfur and oxides of nitrogen are oxidized and are reduced and then the combustion products will be left to the atmosphere will be released to the atmosphere with the help of the stack or chimney. We construct, there are several kinds of stack or chimney. Generally what we do is we construct a very tall conical structure which is hollow inside and that we call it as a stack or chimney and the height will be such that whatever the gases coming out of this will be dispersed in the upper atmosphere so that the combustion gases will not affect the living organisms in that region. And then here the organ gas absorbs heat from the combustion products or combustion gases and from here the organ gas enters the mixer. In mixer we are adding the seed material. Seed material is used because as you know we need ionic gases when the gases passes through MHD system or MHD duct. To ionize, either we need to increase the temperature of gases to very high temperature which is not possible with the available materials because the materials of the combustion chamber, the duct carrying the gases will not be able to hold the gases in ionic state for a longer duration of time. Because of that we use another method that is the seeding method, where we add charged particles into the hot gas. So now the hot gas enters the MHT duct, which is seeded, which contains charged particles that enters the MHT duct through a nozzle. The argon gas which is entering the mixture will be at higher pressure because it is being compressed in the compressor. Now we need to increase the kinetic energy of the gases before it enters the MHT duct, because MHT duct is a device which converts the kinetic energy of ionized gases or ionized fluid into electrical energy directly when a magnetic field applied perpendicular to the direction of flow. So we need to increase the kinetic energy of the gases and we need to reduce the pressure energy. For that purpose we have a nozzle here, or a throttle valve is provided at this place, that is between the mixer and the MHT duct. So here the pressure energy of the gases gets, or argon gas gets converted into kinetic energy. Now we have very fast moving argon gas which is seeded with a charged particle such as cesium particles, and when that passes through the MHT duct, so here we are applying magnetic field perpendicular to the direction of flow of gases, and there will be two electrodes at the which are perpendicular to the magnetic field. So the charged particles which are present here will be deflected by the magnetic field and they get absorbed by the electrodes, and that forms a DC current which is supplied to an inverter. It's a which converts the DC output into 3-phase AC output, and that will be supplied through the existing grid. Then after the gases comes out of the MHT duct, here we have a separator. A separator is a device where we are going to remove the seeding material, because after this the argon gas will pass through heat exchanger 2 and compressor. In the compressor, if the seeding particles are present, then the blades of the compressor gets eroded at a faster pace. So we need to remove all the seeding materials from the argon gas before it enters the compressor. For that purpose, here we have provided a separator which separates solid particles which are present in the argon gas. Then from here the solid particles or the seeding particles will be supplied back to the mixer. After the separator we have heat exchanger 2. Again it is a heat exchanger where it's a shell and tube heat exchanger where inside the tubes the water will be flowing and outside the tube the hot argon gas will be flowing. The hot argon gas will supply its energy or will transfer its heat energy to the water flowing inside the tubes, and that increases the temperature of the water, and in turn it starts to boil water and it converts water into steam. The high pressure steam which is coming out of the heat exchanger 2, or you can call it as a boiler, then enters two separate steam turbines. Here in the first, majority of the steam passes through the first steam turbine which is coupled to a generator. So that generator produces 3-phase AC current, and that will be supplied to households as well as industries through the existing grid. And a small portion of the water steam enters the second steam turbine where that is coupled to the compressor. So we have two steam turbines where the steam expands and produces mechanical energy, but one of them is connected to a generator and the other one is coupled to the compressor which is supplying compressed argon gas to the heat exchanger 1. From here, from both the turbines, the steam comes out and then it is sent to a condenser. It's a indirect contact condenser where the cooling water will be flowing inside the ducts and the steam will be flowing over the duct. As the steam flows over the duct, the cooling water absorbs heat from the steam and condenses that into liquid water. The liquid water is then supplied to the heat exchanger 2. And after that we have this compressor. So the organ gas coming out of the MHD duct will be at a very low pressure, and the same cannot be supplied to the heat exchanger 1. If we supply a low pressure gas into heat exchanger 1, then the amount of energy absorbed by that will be very less, and we will not be able to get very high velocity gas molecules when the gases enters the MHD duct. So for that purpose we need to pressurize the organ gas before it enters the MHD duct. For that purpose we have a compressor here. The compressor is driven by the steam turbine. So the steam turbine and compressor will be mounted on the same shaft. They will be directly coupled to each other. So whenever the steam turbine is rotating, it is compressing the organ gas, and from here the compressed organ gas will be sent to heat exchanger 1, where it absorbs heat energy from the combustion products and then enters the mixture. So here we have two different cycles. One is the cycle of organ gas, which passes through the combustion chamber, mixer, MHD duct, separator, heat exchanger 2 and compressor, and the other cycle is of water and steam, where the water comes from the condenser, enters the heat exchanger 2, gets converted into steam, then enters two different turbines, and from here it again enters back into the condenser. This is the working of closed cycle MHD power conversion system.